Hey guys, welcome back to lecture series on Z transform. For more videos, you can check in my I button here, or you can go through my description box also. There I put my entire playlist for Z transform, Fourier sine, cosine transform. And entire first chapter, it is a linear differential equation with a constant coefficient. You will get all the videos, important videos. As our INSEM and final exam it is coming, guys, you need to be ready for our coming INSEM exam. So these videos are very helpful for you all. Okay, please refer these videos. Now in our today's video, I'm gonna explain to you all third property for Z transform, okay, which says that f of k can be written as a raised to k by k factorial, okay, and when k greater than equal to 0 here. Okay, so I'm going to explain this property. Okay, I'm going to explain this property with the Z transform. What is the Z transform of this sequence? It can be written. Okay, so we know that Z transform of f of k, it can be written as, okay, Z transform of f of k can be written as minus infinity to k running from minus infinity to plus infinity. Okay, this one is a negative infinity, minus infinity to plus infinity, f of k z raised to minus k. Okay, z raised to minus k, it is there. This one is actually definition for Z transform. Already I explained in my last lecture. Okay, yes. Now we are going to replace this f of k as a raised to k by k factorial. Okay, so I'm going to write Z of a raised to k divided by k factorial. Okay, factorial. I know that you all are familiar with the factorial sign. Okay, yes. So if you want the more video based on the factorial and their properties, let me know in comment section. So k running from minus infinity to plus infinity, f of k we have a raised to k by k factorial and z raised to minus k. Okay, yes, this one is our standard property, guys. I'm going to prove this property over here. It's not that difficult. Okay, so you can consider anything over here. You can consider any side here and go for the proving. Now as we have taken simplified form of this z of a raised to k by k factorial using formula this way. Okay, so I'm going to expand this part. Okay, it is way easier to write. Okay, now see that put the value for k is equal to minus infinity to the plus infinity value, it is there. But as we have the value for k is greater than 0, k greater equals 0, so what when we take a k greater equal 0, then what we write? Okay, when k greater than equal to 0, so we write integral summation over k running from 0 to infinity only. Okay, so as we have the value for k, we start from 0 to infinity, that's why I'm taking k 0 to infinity. Okay, a raised to k by k factorial. Okay, a raised to k by k factorial and z raised to minus k. Okay, yes, put the value from 0 to infinity. So first, if I'm going to replace, over here 0, a raised to 0, it is 1. Okay, and 0 factorial, always remember that 0 factorial is the 1. Okay, 0 factorial, it is not the 0, guys. Factorial means 0 factorial is always 1. Okay, so a raised to 0 is 1, 0 factorial is 1, so it goes to the 1. Okay, and z to the power of 0 also, minus 0 means 0, it is also 1. So first term gives us the value 1. Okay, first term gives us the value 1 over here. Okay, and now replace k as a 1. What is the k as 1? So a raised to 1 by 1 factorial, a raised to 1 divided by 1 factorial. Okay, z raised to minus 1. Okay, plus again next a raised to 2 by 2 factorial, a raised to 2 by 2 factorial, z raised to minus 2. Okay, so replace value a raised to 2 by 2 factorial, z raised to minus 3. So a raised to 3 by 3 factorial, z raised to minus 3, plus so on. Okay, next term you will get the a raised to 4 by 4 factorial, z raised to minus 4, a raised to 5 by 5 factorial, z raised to minus 5. Okay, yes, let me sort this term, so in order that we can get the some standard form of terms. Okay, so we're going to write this 1 plus a by 1 factorial, z raised to minus 1. Okay, a by 1 factorial, z raised to minus 1. So give this bracket plus. So after that what we do, take 2 common to the power a and minus z. Okay, so we write a into z raised to power minus 1 to the power 2. Okay, so what I have done, I taken this power 2 out of here, divided by 2 factorial plus a into z raised to minus 1, okay, z to the power minus 1 to the power 3 divided by 3 factorial plus a into z raised to minus 1 to the power 4 divided by 4 factorial plus so on. Okay, this one is our entire term here. Okay, so I hope you all have understood this one. Not the easy, guys. I just taken power to outside here. If you are confused, you can see that if you multiply 2 under bracket a square and z raised to minus 2, it is coming, so it is only original term maintained here. Okay, yes. Now we know that we have one standard expansion. What is the standard expansion for e raised to x? Okay, I already explained the expansion for e raised to x. We can write 1 plus x to the power 1 by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus x raised to 4 by 4 factorial plus so on. This one is the expansion for e raised to x, guys. Okay, this one is the entire expansion for e raised to x. So now see that compare this expansion with this one. Okay, so we can get 1 as 1 here, 1 factorial denominator. What is the value for x? X to the power 1 means 8z to the power minus 1 to the power 1. X square means 8z to the power minus 1 to the power 2. That means what is the value for x is a to the power 8z to the power minus 1. So we got the x as a into z to the power minus 1. So replace this term in the power of e raised to x because these are two equivalent sides. These are the two equivalent sides, so we write x e to the power. Okay, so we got the next step as e to the power a z to the power minus 1. Okay, this one is the next step. So last step we write e to the power a by z. Okay, so whenever we have, this one is important, guys, whenever we have f of k is equal to a raised to k by k factorial, okay, that means z transform of a raised to k by k factorial can be written as e to the power a by z. Okay, z transform of a raised to k by k factorial, z transform a raised to k by k factorial can be written as e raised to a by z. Okay, I hope you all have understood, guys, this entire process for finding the z transform of a raised to k by k factorial. Okay, for your reference you can take note of my notes. Okay, so you can see here I written everything here. Note it down, practice it, guys. Okay, as in same exam it is coming closer. Okay, I hope you all have understood everything here in my today's video. Okay, so just to record single videos, guys, it's really effort, a lot more effort it takes. For one, at least for 10 to 12 minutes video, it takes 30 minutes to record. So I want you to comment me in comment section, guys. If you found anything difficult, confusing, let me know. I will come up with the similar videos. So thank you everyone. Thank you for my today's lecture.